Hello dear students, this is your Professor Lázaro Pino, and today I'm going to show you how to solve problems about the determination of pH in solutions. First of all, let's remember what is an acid. Well, an acid is a solution that produces hydrogen protons in solution, and a base, in the other hand, is a solution that produces hydroxide ions. The way that can be determined the concentration of hydrogen and the way that we can determine the pH of a solution is what I'm going to show you right now. If we are in front of a strong acid, the strong acid is completely ionized, 100% ions in solution. Then we can say that hydrochloric acid, for example, in aqueous solution, is completely in form of hydrogen proton and chloride proton. For that reason is that the concentration of the acid is equal to the concentration of the hydrogen ion. And then applying the formula for pH, that is minus log the concentration of the hydrogen ion, we can find the pH of the solution. If we want to find out the pOH, well, pOH is equal to 14 minus the pH. This way we can calculate pOH. But also pOH is equal to minus log the concentration of the hydroxide ion. And inversely, the concentration of the hydroxide ion is 10 to minus pH. Let's see an example. If the concentration of the hydrochloric acid solution is 10 to minus 1, then we can say that the concentration of the hydrogen ion is also 10 to minus 1 molar. So, pH will be minus log of the concentration of the hydrogen ion, in other words, minus log of 10 to minus 1, that is equal to 1, and the pH is 1. Using this formula, you can calculate pOH. pOH will be equal to 14 minus 1, then it will be 13. And the concentration of the hydroxide ion will be 10 to minus 13. Look, here I made a mistake. It's pOH. The concentration of the OH hydroxide ion is 10 to minus pOH. So, the concentration of the hydroxide ion is equal to 10 to minus 13, that is the pOH. This is a case of an strong acid. But if we are in front of a weak acid, the weak acid, as weak electrolytes, are not completely ionized. Then they are partially ionized. For example, a general acid that is at equilibrium with ions, we have more molecules and less ions. So, you cannot use the same formula that you have used here for the pH. Since the strong acid is 100% ions, you can say that the concentration of the acid is the same concentration of the hydrogen ion. Not in this case. then the concentration of the hydrogen ion in this case is equal to the square root of the constant of the acid. We studied constant of equilibrium. Then, in a similar way, we can find the constant of equilibrium for the acid. This constant is given, you can find them in tables for different acids at certain temperature, times the concentration of the weak acid. For example, if the concentration of the weak acid is 10 to minus 1 molar and the constant of the acid is 9 times 10 to minus 5, then you can say that the concentration of the hydrogen ion is equal to the square root of 9 times 10 to minus 5 times 10 to minus 1. In other words, the concentration of the hydrogen ion will be the square root of 9 times 10 to minus 6. Of course, the square root of 9 is 3, and the square root of 10 to minus 6 is 10 to minus 3. This is the concentration of the acid. So, you can calculate the pH saying that is minus log the concentration of the hydrogen ion. That is 3 times 10 to minus 3. This 3 that is negative here goes multiplying minus 1, and it will give you positive 3. And then you find the log of 3, and you can use your calculator, and then you say log of 3 is equal to 0.48. Then it will be 3 minus 0.48. That is 2.52. That's the pH of the solution. Since you have the pH of the solution, applying this formula that pOH is equal to 14 minus pH, you can find pOH. And so, if you have the pOH, you can get the concentration of the hydroxide ion saying that it's 10 to minus pOH. Well, this is what I wanted you to have in this part of the exercises in the determination of pH of solutions.